Above the city of Cusco, Peru, at an altitude of just over 12,000 feet, sits a set of zigzagging stone walls that has been confusing engineers for roughly 500 years, ever since the first Spanish conquistadors laid eyes on it in the 1530s, and, by their own written accounts, struggled to believe what they were looking at. Sacsayhuaman, built by the Inca as part of the ceremonial and defensive heart of their imperial capital, is made from individual stone blocks, weighing up to 200 tons, cut into complex, irregular, polygonal shapes, no two exactly alike, and fitted together so tightly that a piece of paper genuinely cannot be slid into the joints between them, all without a single drop of mortar holding anything in place. What's actually new here isn't the wall itself, which has been studied for over a century. What's new is a wave of research using radiocarbon dating, ground-penetrating radar, and LiDAR drone surveys, conducted between 2024 and 2026, that has meaningfully changed how archaeologists understand both when this site was built and just how much of it has been sitting undiscovered around the famous walls this entire time. Start with the walls themselves, because understanding what makes them genuinely strange is necessary before getting into what the new research actually found. The stones aren't just massive. Some individual blocks stand over 8 meters tall. They're cut with rounded, slightly bulging faces and curved corners, an unusual pillow-like surface texture that early researchers initially assumed had to be the result of deliberate, painstaking hand carving. Geological studies conducted more recently, using microscopic and chemical analysis of the actual stone composition, have added real nuance to that assumption, identifying that this pillow-like bulging texture, along with certain scoop marks and surface nubs found across many of the blocks, appears connected to natural properties already present in the specific limestone and andesite the Inca chose to quarry, meaning the builders weren't purely fighting the stone into an artificial shape from scratch, but are, at least in part, working skillfully with characteristics the material already had, choosing and shaping stone in a way that worked with its natural tendencies rather than purely against them. That same geological research has also directly and specifically ruled out one of the more persistent fringe claims about the site, that the stones show evidence of having been heated to a molten or semi-molten state and essentially poured or softened into place. Detailed microscopic and chemical analysis has found no signs of thermal alteration or vitrification in the stone at Sacsayhuaman specifically, with the material retaining its fully native, unaltered crystalline structure throughout. A finding worth stating plainly because it directly closes off one of the more dramatic alternative explanations that circulates online. The actual engineering explanation for why the walls are built this way, rather than using simpler, easier-to-cut rectangular blocks, has become considerably clearer through structural engineering research treating the site less as an archaeological curiosity and more as a genuine seismic engineering problem worth modeling directly. Cusco sits in an active seismic zone, on top of fault lines capable of producing significant, damaging earthquakes, and a team of structural engineers publishing detailed seismic analysis using rigid body dynamics within a finite element modeling framework, specifically applied to an actual wall section at Sacsayhuaman, has demonstrated mathematically how the site's specific construction choices function as a genuinely sophisticated form of earthquake engineering. Because the individual stones are irregular, interlocking, and unmortared, rather than bonded rigidly together the way a mortared rectangular brick wall would be, they're able to move independently against each other during a seismic event, sliding, rocking, and vibrating slightly as the ground shakes, dissipating and spreading out the earthquake's energy across the entire wall structure instead of concentrating stress at fixed joint points the way a rigid mortared wall does. The irregular interlocking polygonal geometry then acts as a kind of natural self-centering mechanism once the shaking stops, the specific puzzle piece shape of each stone naturally guiding it back down into its original tightly locked position, rather than leaving it permanently displaced or cracked. This is precisely why Sacsayhuaman, along with other major Inca stone structures built using the same general technique, has survived numerous significant earthquakes over 5 centuries with its core structure still substantially intact, while considerably newer buildings constructed nearby using rigid European-style mortared masonry have repeatedly suffered serious damage or outright collapse during the same seismic events. It's a genuinely elegant engineering solution, arrived at centuries before modern seismology existed as a formal scientific field, built entirely through empirical trial, accumulated construction experience, and presumably no small amount of hard-won lessons from watching earlier, less sophisticated structures fail. The actual how of the stone shaping and fitting process itself has real, demonstrated experimental archaeology behind it too, most notably from the researcher Jean-Pierre Protzen, whose detailed hands-on studies of Inca stoneworking techniques remain a foundational reference in this field. Protzen's experimental work demonstrated that Inca masons achieved this level of precise, individualized fitting primarily through a careful, iterative process, of repeated test fitting and grinding, using hard stone hammerstones to progressively shape each new block. I'm then physically testing it against its neighboring stones already in place, marking and removing high points where the fit was too tight, and repeating this cycle patiently until an extremely close fit was achieved. A genuinely time-intensive, skill-dependent process, but one that requires no lost technology or exotic tool to explain, simply patient, iterative craftsmanship, refined over what was likely generations of accumulated masonry experience across the wider Inca construction tradition. It's also worth noting directly that a small number of contrarian, non-mainstream papers have circulated proposing far more speculative explanations, including one claim that Sacsayhuaman was actually built by European colonial masons in the 17th century using pantograph-based stone copying technology, connecting it to unrelated polygonal masonry traditions in Cambodia and Egypt as evidence of a shared, otherwise undocumented, global guild of builders. This specific claim sits well outside mainstream archaeological consensus, isn't supported by the extensive, well-documented Spanish colonial-era written record which describes Sacsayhuaman as already an established, functioning Inca structure at the time of conquest, and hasn't been accepted or engaged with by the broader field of Andean archaeology. Worth mentioning here, mainly because it does circulate online and deserves to be identified clearly as a fringe position rather than a credible competing theory. Now, to what's genuinely new. In 2024, archaeologist Alexei Vranich, whose earlier work on Pumapunku in Bolivia we've already covered in detail, led a fresh excavation campaign at Sacsayhuaman itself, opening 6 separate trenches across the site specifically to collect organic material suitable for radiocarbon dating, a direct, physical dating method considerably more reliable than the stylistic and comparative estimates archaeologists have historically had to rely on for much of the site's construction history. That radiocarbon work, combined with a broader, deliberately expanded research program, has been specifically aimed at testing and refining the existing chronology of when construction at the site actually began, with early results feeding into a larger scientific push led by Vranich's team to challenge an older assumption that Cusco was only a relatively modest, incipient settlement during the late intermediate period, immediately before the Inca Empire's major imperial expansion. Instead, the accumulating evidence from this newer research points toward a more monumentally organized, deliberately planned proto-urban center, already taking shape considerably earlier than previously assumed, meaning the sophisticated planning and organizational capacity behind Sacsayhuaman's construction may have developed over a longer, more gradual timeline than the traditional narrative, which tends to credit the famous zigzag walls primarily to the reign of a single specific emperor, has generally suggested. Running alongside that excavation work, a separate and genuinely striking research effort has been investigating what actually lies beneath and around the visible walls. In October 2025, Peruvian archaeologists Mildred Fernandez and Jorge Calero, leading a project called Proyecto Chinkana Cusco, used ground-penetrating radar to investigate long-standing local oral traditions, describing an extensive network of underground tunnels, referred to in Quechua as the Chinkana, meaning labyrinth, or place where one gets lost, said to connect Sacsayhuaman with sacred temple sites elsewhere in the city, including the Coricancha, the Inca Empire's most important religious temple. These oral traditions had circulated for generations among local communities and had also been referenced by Spanish colonial-era chroniclers, but had historically been treated with real skepticism by professional archaeologists, given the lack of any direct physical evidence to confirm them. The 2025 radar survey changed that. According to the project's findings, the ground-penetrating radar data confirmed the presence of an actual underground stone-built tunnel system, with survey results indicating it may extend for as much as 1,750 meters, physically connecting Sacsayhuaman to the Coricancha, roughly in the manner local tradition had long described, an archaeological confirmation of oral history that had persisted, unverified, for centuries. The most recent and arguably most significant addition to this picture came in early 2026 from an Italian research team working as part of the CNR ISPC Missione Itaca project, using drone-based LiDAR to conduct an extensive remote sensing survey across a much wider area surrounding the famous walls than had previously been systematically studied. LiDAR, a laser-based remote sensing technique capable of digitally mapping ground surface features in extraordinary detail, including subtle terrain modifications hidden beneath vegetation or years of soil accumulation that are effectively invisible to a person simply walking the site, revealed something researchers hadn't previously mapped in this level of detail: an extensive hidden urban system of roads, agricultural terraces, and additional structures spread across the wider landscape surrounding Sacsayhuaman, particularly concentrated around 2 specific elevated sectors known as Cruz Mo'qo and Muyumarka. The three-dimensional models generated from this LiDAR survey data show clear evidence of substantial, intentional modification to the natural terrain at these locations, including the construction of platforms and terracing walls that researchers now believe likely predate the construction of the famous colossal polygonal walls most visitors actually come to see, suggesting the wider ceremonial and urban landscape around Sacsayhuaman developed in phases, with meaningful large-scale human modification of this specific hillside, beginning well before the iconic zigzag walls themselves were ever built. Taken together, what this current wave of research actually adds up to isn't a single dramatic new secret hiding inside the famous walls themselves. It's a genuinely significant expansion of the entire picture surrounding them, real radiocarbon dating work potentially pushing back how early large-scale organized construction activity began at this specific hillside. Real ground-penetrating radar confirmation of a genuine underground tunnel system that oral tradition had described for generations without any archaeologist being able to confirm it, and real LiDAR mapping revealing that the famous walls people travel from around the world to photograph were never really an isolated structure at all, but rather the most visible, most monumental piece of a much larger, more complex urban and ceremonial landscape that Inca and pre-Inca builders had been actively shaping across this hillside in stages over a considerably longer span of time than the traditional simplified version of Sacsayhuaman's story has generally given them credit for. None of it requires lost technology or an inexplicable engineering mystery to make sense of. It requires patient masons, sophisticated empirical seismic engineering worked out through generations of trial and consequence, and, as it now turns out, a considerably larger and more ambitious construction project spread across the landscape than researchers had fully appreciated until drones and ground-penetrating radar finally gave them the tools to see all of it at once.